Number 11. Show that the power is P delivered to an electric device is equal to the current passing through the device multiplied by the potential difference across its terminal P equal I delta V. I think all of us know that power equal I multiplied delta V. For battery, power equal I square R. For resistance in series, power equal V square over. For resistor in what? In parallel, and power equal energy over time. Energy, we can write it U or we can write it E. Solve a problem involving electric power, energy and power in electric circuit. All of this equation related to power. The unit of power is what is watt. If I need to convert from kilowatt to watt times 1000, if I need to convert from watt to kilowatt, divide by 1000. The unit of electrical power is kilowatt hour, because as you see from this equation, energy equal PT. Energy equal power multiply what? Multiply time. In case of power in kilowatt and the time in hour, the unit of energy kilowatt hour, and this related to the electrical bill. Electric bill equal power in kilowatts times time in hour multiply price in dirham per kilowatt hour. The first question. A 12-volt battery delta V with internal resistance 4 ohm is attached across an external resistor of resistance A. Find the maximum power. Maximum power when internal resistance equal external resistance that can deliver to the resistor. Suppose we have battery like this. This battery is connected to the resistance with R. Inside the battery there is electromotive force and internal resistance. When internal resistance equal external resistance, the maximum power delivered to this resistance. So that internal resistance is what? 4 ohm. External resistance equal also 4 ohm. This battery is 12 volt. The first step, Req equal 4 plus 4 equal what? 8 ohm. Number 2, total current equal delta V over Req equal 12 over 8, 1.5 ampere. The third step, power maximum delivered to this resistance equal I square multiply R, 1.5 square times 4 using the calculator. 1.5 square times 4, the answer is 9 watt. 100 watt, its power light bulb is connected in series to across EMF with 100 volt delta V. When the light bulb is lit, what is the resistance? We have resistance for this light bulb, power equal V square over R, so that R equal what? V square over P, 100 square over 100, R equal 100 ohm. First one, 9 watt. Number 3, how much money, you ask about cost, will pay to electric company if we turn 100 watt its power? I need to convert it to kilowatt, divide 1000, light bulb, and leave it on for an entire year. Time equal 1 year. How to convert from year to hour? First step, time equal 1 year. Year is 365 days and the day is 24 hours. The answer is 365 times 24, 8,760 hours. The second step, cost equal power in kilowatt multiply time in hour multiply price. The cost of electricity is 0.12 dirham per kilowatt hour. It means 100 divide 1000, it's power, multiply 8760 times 0.12. The answer is 100 over 1000 times 0.12, 105 dirham. Number 4, 3 resistors are connected across a battery as shown in the figure. How much power is dissipated across the 3 resistors? We need power total dissipated across all of this resistor. First of all, we have 2 resistors connected in what? In parallel, exactly. So that equivalent for this 2 resistor is 192 divided 2. It's equal 96 ohm. This resistance will connect it in series with another one. Req in this case, it's equal 192 plus 96. It's equal 288 ohm. The second step, I total equal delta V over Req, 120 over 288 ampere. The third one, power total, it's equal I multiply delta V, equal I 120 over 288 times 120. The answer is 120 square over 288. It's equal 50 watt. The total power delivered from battery to all resistor is equal 50 watt. Number 12, about Kirchhoff's loop rule. We discussed it in the previous question. Apply Kirchhoff's loop rule to a single loop circuit, figure 6.8. Look to this example. In the circuit shown, R1 equal 5, R1 equal 5 ohm, R2 equal 10 ohm, R3 is 15, V1 is 10, V2 is 15 voltage. The current move in this direction, positive and negative, positive and negative, positive and negative. Using Kirchhoff's loop and junction law, determine the currents I2 and I3. We have I1 0.091 ampere. Look to this loop. We have 2 unknown, I2 and I3. And this loop we have only 1 unknown, I2. I start with this loop, loop number 1. I move clockwise, starting from this point. Out of this element is positive. Positive what? 5 times 0.091. Then out of this is positive 15. Then negative I2 times 10. 10 I2. Then negative 10 equal to 0. How many unknown? Only 1 unknown. We can use shift solve. 5 times 0.091 plus 15 minus 10 equal this number to another side in negative sign and divide by negative 10. Divide by 10. I2 equal 0.5455. I2 equal 0.5455 ampere. From what? Loop number 1. Then I take loop number 2 in the same direction, clockwise, starting from this point, positive 10 I2. 10 multiply I2 is 0.5455. When I get out from the battery, I found a negative 15 voltage, continuous in the loop, positive 15 I3, reach to the same point equal to 0. How many unknown? Only unknown. We can solve it by shift solve. 10 multiply answer minus 15 equal negative this number to the another side by positive. divide 15. I3 is 0.64 ampere. Number 13. State Kirchhoff's junction rule. The sum of the current entering a junction must equal the sum of the current leave the junction. Entering current equal out current. Enter current, inward current, we consider it positive. Outward current, we consider it negative. Let's start with this question. In the junction shown, which equation correctly expresses the sum of the currents? We have I1 enter this junction, so that I1 is positive. I write positive I1. What about I2? Enter also positive. I3 leave, it's a negative I3. I4 in, positive I4. I5 in also, plus I5. I6 out of the junction, negative I6, equal to 0. This one. Question 2. In the junction shown in the figure, what is the value of I? I is enter is positive. 3 enter, positive also. 4 leave, it's a negative. 2 leave also negative, equal to 0. As you see, I 3 minus 4 minus 1 minus 1 minus 2 is equal minus 3 equal to 0. I equal to 3 amp. Number 14, solve a problem on Wheatstone Bridge. Solve a problem 6.2. Wheatstone Bridge, it comes like this shape connected to the battery, and we have 4 resistors, R1, R2, R3, R4. And there is a bridge between these 2 points. If there is an ammeter in this bridge, and the ammeter reading 0 amp. In this case, it means R1 over R3 equal R2 over R4. In case of the ammeter reading what? The ammeter reading 0. If I put any resistance in this bridge, any resistance in this branch, we can neglect it. We can delete it. Why? Because there is no current to pass through it. Look to this example. As you see in this figure, what is the equivalent resistance of the set of the resistors shown in the figure? 10 over 5 equal what? 10 over 5 equal to 6 over 3. 6 over 3, it's equal to also 2, the same in both sides, so that there is equilibrium. In this case, we can cancel this resistance. There is no current to flow through this one. After I delete this resistance, we have 2 resistors connected in the same branch, 10 ohm and 6 ohm, and another 2 resistors connected in another branch, 5 ohm and 3 ohm. 10 and 6, it's equal what? Equal 16 ohm. 3 and 5 equal 8 ohm. 16 and 8 connected in what? Yes, connected in parallel. In this case, Req equal 16 times 8 over 16 plus 8. Using the calculator, 16 times 8 over 16 plus 8, the answer is 5.33, 5.3 ohm. Question number 15. Recall that an ammeter is a device to measure current. Ammeter connected in series in the circuit. Ammeter has a small resistance, and the voltmeter is device to use potential difference. Voltmeter connected in what? In parallel, and the voltmeter has a high resistance. When being used to measure current, an ammeter should be connected in what? Connected in series with what? In the circuit. Connected in series with the circuit. Number 5. An ammeter has internal resistance. Internal resistance, it's Ra, and require a current of 1 microampere for full scale deflection. It means the current for this ammeter, Ia micro, multiply 10 to the negative 6. If the shunt resistance is Rs, needed to produce a full-scale current of 12 ampere, I total after increasing the range. For the same ammeter is 3.5 micro ohm. It's Rs. Rs is equal this number. What is the resistance of the ammeter? Ra equal what? Rs equal Ia times Ra over I minus Ia. We can consider it I total. Rs shunt resistance, small resistor connected in parallel inside the ammeter to increase the range. Ia ammeter current, small current. Ra ammeter resistance, internal resistance for the ammeter. I total the current we need to measure it after the increasing the range. Ia is ammeter current. Rs 3.5 multiply 10 to negative 6. I ammeter is 1 times 10 negative 6 multiply R ammeter unknown over I total is 12 minus 1 times 10 to negative 6. Shift solve. 3.5 times 10 negative 6 alpha equal fraction 1 times 10 negative 6 times unknown over 12 minus 1 times 10 negative 6. Shift solve equal 41.9. We can consider it 42. R ammeter equal 42 ohms. The internal resistance of the ideal ammeter, internal resistance equals zero resistance.